Have you ever stopped to consider how much math you use in your daily life? Let's take a moment to ponder this. When you wake up in the morning and glance at your clock, you're using numbers to understand the time. As you prepare your morning coffee, you measure out the right amount of water and coffee beans. That's math. And let's not forget about that budget you set for your monthly expenses, or the change you calculate when you buy something at the store. Yes, these are all everyday examples of how we use mathematics. Think about when you're cooking a meal. You carefully measure out the ingredients according to the recipe. That's fractions at work, and when you double a recipe or reduce it, you're performing multiplication or division. Then there's travel. Whether you're driving, biking, or walking, you use math to calculate how much time you need to reach your destination. You're also using geometry and spatial reasoning when you navigate the streets or when you park your car. And it's not just about numbers and measurements. Mathematics also plays a vital role in our decision-making processes. When you're deciding which brand of cereal to buy, you're comparing prices and sizes, trying to figure out which one offers the best value for money. That's ratios and proportions in action. Or consider when you're planning your day. You need to fit in work, meals, exercise, relaxation, and sleep. That requires you to divide up the 24 hours in a day effectively. Again, that's math. Even our leisure activities involve math. When you're playing a board game or a card game, you're using probability to strategize your next move. And when you're doing a jigsaw puzzle, you're using pattern recognition and spatial reasoning, both of which are fundamental mathematical skills. As we can see, mathematics is not just a school subject, it's an integral part of our daily lives. The numbers, the calculations, the ratios, the patterns, they're all around us, shaping our world in myriad ways, often without us even realizing it. Now let's travel back in time to the birth of mathematics. Our journey begins in the cradle of civilization, where the ancient Babylonians laid the groundwork for modern arithmetic and geometry. They were the first to develop a positional number system, a concept that would later evolve into the decimal system we use today. This allowed them to perform complex calculations and devise mathematical solutions to real-world problems, such as dividing land and tracking lunar cycles. We then journey to the banks of the Nile, where the ancient Egyptians used mathematics to construct their monumental pyramids. The Egyptians developed a practical system of mathematics based on units of 10, similar to our current system. They used this system to solve problems related to taxation, commerce, and architecture. Their mastery of geometry was instrumental in the precise alignment and construction of the pyramids, a testament to the power and practicality of mathematics. Our voyage continues to ancient Greece, where mathematics took a philosophical turn. The Greeks viewed mathematics not merely as a tool for solving problems, but as a means of understanding the fundamental nature of reality. They gave us the concepts of mathematical proof and logical deduction, which remain at the heart of the discipline to this day. Famous mathematicians like Pythagoras, Euclid, and Archimedes left an indelible mark on the field, their theories and discoveries still taught in classrooms across the globe. These ancient civilizations were the pioneers of mathematics, their innovations forming the bedrock of countless fields and disciplines. They recognized the power of numbers and shapes, the elegance of symmetry and proportion, and the thrill of discovery and understanding. From these early beginnings, mathematics has grown in complexity and sophistication, shaping human history in profound ways. Their legacy lives on in every calculation, every equation, and every mathematical truth we uncover. So as we explore the intricate world of mathematics, let's remember the foundations laid by these ancient civilizations, and the journey that has brought us to where we are today. Mathematics has played a pivotal role in scientific advancement. It's not just about solving equations or crunching numbers. Mathematics is the language that scientists use to describe the world around us, and it's the toolbox that allows us to make sense of complex phenomena. Let's take a look at physics. The laws of motion, the theory of relativity, quantum mechanics. These are all built on mathematical principles. It was the genius of Sir Isaac Newton who, in the 17th century, developed calculus, a branch of mathematics that deals with rates of change and the accumulation of quantities. This allowed him to formulate his laws of motion and universal gravitation, fundamentally changing our understanding of the physical world. Chemistry, too, owes a debt to mathematics. The periodic table, the cornerstone of modern chemistry, is an example of how mathematical patterns can reveal fundamental truths about the universe. It was through recognizing patterns in the properties of elements that Dmitri Mendeleev was able to predict the existence of elements yet to be discovered. In biology, mathematics helps us understand the patterns and processes of life. From the spirals of a seashell to the growth of populations, mathematical models allow us to predict and understand biological phenomena. For example, the Hardy-Weinberg principle uses algebra to predict how genes are inherited from one generation to the next. Engineering is another field where mathematics has been instrumental, from designing bridges and skyscrapers to developing advanced technologies like computers and spacecraft. Engineers rely on mathematical principles to ensure their designs are safe, efficient, and effective. And let's not forget about medical research. Statistics, a branch of mathematics, plays a key role in understanding disease patterns, testing new treatments, and predicting health trends. It's thanks to statistical analysis that we can determine the effectiveness of a new vaccine or predict the spread of a pandemic. So, mathematics is not just about numbers and equations, it's the language of science. It's the tool that allows us to explore, understand, and manipulate the world around us. Whether we're calculating the trajectory of a rocket, predicting the spread of a disease, or designing a new piece of technology, we're using mathematics to make sense of our complex and ever-changing world. In our modern world, mathematics is more important than ever. As we navigate through the 21st century, the influence of mathematics permeates every corner of our lives, from the technology we use, the economies we participate in, to the structures we inhabit. Let's start with technology. In the heart of our computers, smartphones, and the internet, mathematical principles are hard at work. They form the backbone of algorithms, which are nothing but step-by-step procedures for calculations. These algorithms dictate everything from how your social media feed is personalized, to how your GPS navigates you through the city. Coding, the language of our digital age, is deeply rooted in mathematics, transforming abstract ideas into concrete solutions. Switching gears to economics and finance, mathematics again takes center stage. Mathematical models are the crystal balls of our economic systems, predicting financial trends and guiding decision-making in business and investments. From the stock market's complex calculations to the simple interest on your savings account, mathematics is the invisible hand that guides economic prosperity and stability. Now let's consider the world of architecture and engineering. Here, mathematics is the silent architect, shaping our world in both tangible and intangible ways. Geometry and calculus in particular play a significant role. They help architects and engineers design and construct everything from humble homes to towering skyscrapers, from quaint bridges to sprawling highway systems. Through mathematical principles, we've been able to transform our physical world, creating structures that are not only functional but also aesthetically pleasing. In essence, mathematics is the universal language that transcends cultural and geographical boundaries. It's the tool that helps us decipher the world around us, solve complex problems, and create innovative solutions. It's the invisible thread that connects different fields, fostering interdisciplinary collaboration and pushing the boundaries of human knowledge and creativity. No matter where we look, we can see the fingerprints of mathematics. It's intricately woven into the fabric of our modern world, silently shaping our lives in ways we often take for granted. As we gaze into the future, the importance of mathematics only seems to grow. The advent of artificial intelligence, for instance, is a testament to the power of mathematical algorithms. These algorithms, which rely heavily on complex mathematical principles, are responsible for teaching machines to learn, adapt, and make decisions. From self-driving cars to voice assistants and predictive text, artificial intelligence is gradually transforming the way we live and work, all thanks to mathematics. Then there's quantum computing, a field that's pushing the boundaries of what's possible in the realm of technology. Quantum computers, unlike their classical counterparts, leverage the principles of quantum mechanics, a branch of physics grounded in mathematics, to process information in ways that were once thought impossible. They hold the potential to revolutionize numerous fields, including cryptography, material science, and medicine, by solving problems that are currently beyond the reach of even the most powerful supercomputers. Data science, too, owes a great deal to mathematics. It uses mathematical models and algorithms to make sense of vast amounts of data, turning raw information into valuable insights. These insights play a pivotal role in various sectors, from healthcare and finance to marketing and logistics, enabling organizations to make more informed decisions and predict future trends. But perhaps the most profound impact of mathematics lies in its ability to foster problem-solving skills. As the world becomes more complex and interconnected, the ability to think critically, analyze information, and solve problems is more crucial than ever. And it's mathematics, with its emphasis on logical reasoning and systematic thinking, that equips us with these skills. So, whether we're talking about the next groundbreaking technology or the challenges that lie ahead, one thing is clear. Mathematics will play a key role. It's not just about numbers and equations. It's about understanding the world around us and making sense of the unknown. As we continue to push the boundaries of knowledge and technology, mathematics will remain our most reliable guide.